Hello. So this is the demo for JAX introduction and how to use it in deep learning. So like PyTorch and TensorFlow, JAX is another a framework to use used in neural networks. So it's a high performance numerical computing library developed by Google that combines NumPy like API. So the syntax is very familiar, and automatic differentiation, so the grad function which you use for computing gradients, and JIT compilations, so accelerated code, and vectorization for atomic batching, parallelization for multiple device computation. So it's just now it's comparison of all the four: NumPy, PyTorch, TensorFlow, and JAX. So NumPy like API, these two didn't have that, but yeah, it was similar but not same. But JAX is very similar to NumPy. Auto differentiation is there. It is there in PyTorch, TensorFlow, and JAX, but not in NumPy. JIT compilation is present in PyTorch, TensorFlow, and JAX. Functional paradigm, it's there in JAX. Pure functions and composable transforms. So as you can see, it's more capable and more high performance library. So yeah, so JAX embraces pure functions that always produce the same output with the same input and won't have no side effects. So this is how we import it. And if we do .numpy as jax.numpy as JNP, we can use the JAX version for of NumPy and use it. So we can just directly take grad, JIT, vmap, and random function from it. These are the key JAX transformations. Yeah, so again, this also uses GPU. So yeah, again, now it's the same here. The data type where the data is stored in a very fundamental level is tensor. So how to create it? We can create it using array function, which will create the scalar value. We can give a list as well, so it will give a one dimensional. We can give a list of lists, so it's a 2D vector. And we can have a multiple high dimension tensors created out of it. Special functions like zeros and ones is also here. um, uh, a full function where you can have a matrix of this size with the value 7 filled throughout. Identity matrix is I. Again, a range function and line space like we have in TensorFlow and PyTorch. We can have random values assigned to the vector, which is how the neural starts in the initial state. So yeah, this random number generation, it's unlike NumPy and PyTorch. JAX uses explicit PRNG, so pseudo random number generator keys. So it's a when we do NumPy random.js, this modifies the hidden global state, whereas when we use this PRNG, it gets it has the explicit state, so it gets new key for next use. So there's no hidden state. So yeah, so that is why it makes the functions pure, and it enables in GIT compilation. So yeah, again, it supports different data types like float 16, 32, 64, int 32, 64, and boolean. And type conversion, typecasting is also allowed. You just have to do as type and provide the required data type. It will convert it. And then array attributes are like shape, n dimension, size, data type, and devices. These are the same as we did in PyTorch and NumPy. PyTorch, NumPy, and TensorFlow. Indexing same works as the same. You just have to give start, stop, and step. And yeah, Boolean, and it also supports Boolean indexing, filtering values based on some condition. And yeah, JAX arrays are immutable. So anytime you create one, it is going to be a new one created, and we cannot change the values of it. So whenever we are changing the value, it is creating another variable of the same format and then pointing it to it. Then we have element-wise operations, same before, addition, subtraction, like that. Also, trigonometric functions are available. Other mathematical functions are also available. Broadcasting is also same as TensorFlow and PyTorch. Then we have reduction operations, like some mean, max, the other statistical information we can get out of the data. Yeah, and then we can also reshape the data as we did in PyTorch and NumPy, PyTorch and TensorFlow. We can also, create a transpose of the matrix. We can flatten it, expand the dimensions of it, squeeze the squeeze a vector into a smaller dimension. Concatenation and stacking was also, for concatenate we use the whole full term concat, and stack is stacked. Excuse me. Then yeah, that is pretty much it. Thank you.